Um, Hi guys, Frankenstein here. So I want us to check out this one now. It's a bias series circuit or bias series clipper circuit, right? So what they want us here to find is the output wave. So they give us the input wave. So the input wave is basically looking like this. Just draw it a bit top there. Something like that, and we have a sine wave like that. Don't mind my sine wave because it's not that straight, but you might get the thing of it, right? They just are trying to symbolize. So also now I almost got ahead of myself right there. So what you do is draw those dots there to indicate, to differentiate between the negative cycle and the positive cycle, right? So one thing I can tell you first before doing this problem is that you look at the diode, and you look what sign is close to it. So the sign which is close to it is that it is a negative sign. So this tells you that this biasing will shift the waveform to the negative part, to the negative side of the graph, right? So it's gonna shift this reference point to the bottom because it's a negative, right? So when it shifts it, it has to look something like that. Let me show you something. Down, and then let's say that referencing point is there. Let's say it's there. That is negative V, because remember I indicated that voltage as V, right? But now remember that we have V max there and we have negative V max, right? So how are we gonna find what is these points here, right? So what you do, since you've shifted this graph to the bottom, right? So if you shift this graph to the bottom, meaning that on this V max, you're gonna say the new voltage, let's say V max new is gonna be equal to V max minus V, right? So for that one, now for this one now, it's gonna be negative V max new is equal to a negative V max minus V again. Now take into account, actually let me write it this way so that to distinguish it from that. So open bracket V max plus V. So what I'm trying to do is that you know that this voltage will be negative, so it's gonna be what? Negative into V max plus V, because you are taking it more down. Yeah, bro. So meaning that what you have is basically this same waveform, but the reference point will be different. So meaning that you're gonna do the very same waveform, but the reference point will be different. So like that, it won't be shifted anyway. It's the same thing. Let me try and write it perfectly fine. I'll be looking weird and everything. Oh my word, doesn't look like that. There you go. And that, yes. Now that one, it will be V max new, and this one, it will be negative V max new. Ne? Now that is a negative V max new. But now let's look at the waveform. Is it complete now? It's not complete. Why? It's because once we were accounting for the biasing there when we're doing this analysis, we're not done with the biasing. So what we need to do is check how do we account for that biasing there, right? So now we've done the effect of the biasing on the sine wave. We've done the effect by shifting the graph to the bottom, right? So how do we find the output wave? This is not the output wave. This is not the output wave, by the way. It's not the output wave. So the output wave, it has to be accounted for by removing this biasing, because we've accounted for it. So we can remove it now. Let's remove that biasing there and replace it with short, because we've accounted for it from the circuit. Because now we've removed it. That's a normal circuit. So what we'll do is understand for the positive cycle, will this function be operating now? No, it won't, because this diode is in the reverse biased, right? So if it's in the reverse bias, meaning that the whole positive cycle will be clipped off, right? Now we come back again and say for the negative cycle, where we know the polarities will be changed, therefore we'll have negative and a positive there, therefore current will be flowing in this direction. Will the diode be on? Yes, the diode will be on. So meaning that this whole part is clipped off, but the bottom part will appear as it is, right? So meaning that our output wave will be looking like this. So output wave, there it is, wave will be like that. Let's see, show you that. So it will be the referencing point, remember, very important. Actually, let me draw a different color. So that is referencing point, and then showing our thingy there which we had, and then so to draw that, and remember we said this won't be available, so we can erase it. Oh my word. Okay, let's try and draw it. I don't know how I'm gonna draw it, but let's draw it. There you go. It appears perfectly fine. So meaning that right there on the bottom, that is a negative Vmax. Yeah. So, well, if you want to indicate this Vmax as something else, you can indicate it as negative into Vmax plus V, referencing to the circuit itself. So I feel like that's about it. But now let's go into another circuit, the other circuit on the different side, where I have changed the polarity of the battery, and see, let's check the effect of that polarity there. So same thing you're gonna do here. You're gonna draw the input wave, which is looking something like that. It's an AC wave, so something like that. And then this is the positive cycle, negative cycle. And what we need to do is account for the biasing first. And what did I say for the biasing? You look at the polarity, you look at the diode itself first, and you shift your focus to the sign next to it. What is the sign there? It is a positive sign. And that tells you that, no, bro, I've been shifted to the top, because I've been shifted to the positive side. I've been shifted to the positive side because I'm trying to go towards the positive, because if you can check, the arrow is pointing towards the positive, sorry. So that's what we're gonna do, is shift that waveform to the positive side, or referencing it to the positive side. And remember that voltage which I'm applying there, it's called V. So I will change my referencing point to V. My reference point will be V, and I have another point there which is called Vmax, and I've got negative Vmax here. Did something wrong. Now negative Vmax, yes, Vmax, yes. Now we come back again and find how we're gonna find our new voltages. So Vmax, that is, and this is negative Vmax. Now for us to find this positive Vmax, right? So the new Vmax, we know, when I know the peak, now we are accounting for the biasing now. We're not accounting for anything else. So meaning that we're gonna say positive Vmax new is equal to what? Vmax plus V, ne? That we are having the new peak as Vmax plus V. And then the negative Vmax new is equal to negative into Vmax minus V. Are we still fine? Now we are subtracting some voltage from the Vmax on the bottom. Why? Because we're trying to shift it to the top. So meaning that the voltage referencing will start from here, right? So if we draw a waveform, it will be from here towards what? Vmax plus V. So it will be a bit higher, and then go down to Vmax minus something, and then come back and reference into the same section. It was referencing towards the same section. It's not referencing to another section, but towards the same section. Ne? And then what we need to do here is check again now that since now we've got this point now is shifted a bit. It's no longer Vmax. I lied here. It's not Vmax, but it's Vmax native, Vmax new, right? New. But if we're gonna account for that point, it's still the same thing. But that point there will be what? It will be Vmax minus V, and then everything into negative parentheses. And then that point there, it will be what? It will be Vmax plus V. Okay? And now I said this is not the output. This is not the output wave. Not output wave. I'm still repeating this again. So what we did in this graph here, we were analyzing on what the battery is doing, the DC battery is doing to the circuit. We're checking that. So now let's go and find that what is the actual output wave. What are we gonna do after that? So what we're gonna do is gonna replace that battery, because we've taken the effect of that battery in the circuit. What we're gonna do, we're gonna remove that battery and replace it with a short circuit, right? So let's remove that battery, then replace it with a short circuit, so that we can analyze this wave properly, because the battery is like causing problem and stuff. So now yes, now we've got a normal clip-off circuit, normal negative clip-off circuit, sorry, positive clip-off circuit. So now we have this diode, right? No, what is this diode gonna do? This diode is basically gonna close any positive cycle waveform coming in. So no current will flow for the positive cycle. Now if we change the polarities now and say now I have negative here and I've got positive here, the current will flow in this direction. So meaning that whatever is happening, whatever gibberish is happening here is clipped off. Whatever gibberish is happening here is being clipped off. Any gibberish there on top, on the positive cycle, is being clipped off, right? So meaning that my output waveform will be something looking this way. Let's see. Somewhere here, right? And everything is just gibberish. It's just like 0 volts. So everything there will be just 0. So this and this voltage, remember, let's take account of that voltage there. And that voltage there is actually Vmax minus V, everything into negative parentheses, like I said on the other side. Now that is the output wave. So that is the output waveform. So yeah, I think that's about it. So yeah, meet in the next one, guys. In the next one we'll be having like numbers in these circuits, and to see what's actually like happening and what am I actually saying with like Vmaxes and V's. So we're gonna actually have actual example with numbers inside, like actual voltages, and also that you can see what's actually happening in there. Yeah, but anyways guys, thank you for staying tuned till this far. Hopefully you subscribed so you can be notified next time I upload another video on such circuits. And yeah guys, take care. Happy studying. Yes man.